Let's finish up lesson 6.7 with a couple of problems. We're going to start with a warm-up problem. And our warm-up problem is going to be a continuation of example 4a. If you have printed off notes, you should have room to complete this in the column on the left. If not, just add this problem below and then we'll do example 4b. It says, as a warm-up, write the series in example 4a using sigma notation. Then find the sum. So we hadn't done that yet. Now sigma notation is what example 3a up above looks like. And that's what we want to do here. When we write in sigma notation, we need that weird little e symbol. We start with n equals 1. And we continue on to the total number of terms. Well, we calculated that yesterday. The total number of terms is 10. And then to write the sigma notation formula, that's just the explicit formula. So we really just plug in 200 times 1.5 to the n minus 1. So we had to do all that work from 4.a to get our answer using sigma notation. And now let's find the sum. The sum is going to take a little bit more work if you remember the formula from yesterday, but a calculator will be super helpful. The sum of these 10 terms is going to default s sub 10, and that will equal the fraction a sub 1, which is 200, times 1 minus r to the n power, 1.5 to the 10th, all divided by 1 minus 1.5. If you plug in that parenthesis all at once, well actually the entire top row, that's what I would do. Take 200 times, in parentheses, 1 minus 1.5 to the 10th power, parentheses. You would get a really big number that I didn't write down. Hang on. Okay, now I have it. I typed it all in and then I forgot to write out that part. So if we take 200 times 1 minus 1.5 to the 10th power, we get negative 11,333 a lot of decimals here, 0.07812 divided by, and then in the denominator, 1 minus 1.5 is negative 0.5. If you divide that out, negative 11,000 and so on, divided by negative 0.5, the sum of those 10 terms actually changes to positive, which should make sense because all the numbers that we see in that series are positive. We'll get 22,666.015625. Now that would be the exact sum. I didn't round anything there. So depending on what the directions tell you, you would maybe want to round accordingly. All right, let's finish up with example 4b. And now we have the sum. The sum of a geometric series is 11,718. The first term is 3, and the common ratio is 5. So that means we're multiplying by 5 each time. How many terms are there in the series? This is another way we can use logarithms as a guide to help us solve. If we default our sum formula, we don't know what n equals. We'll plug in a sub 1 times 1 minus r to the n all over 1 minus r. Now, the parts we know a sub 1. That's 11,718. No, that is not. Wow, sorry. That's 3. We know that the common ratio is 5. The sum is the 11,718. Let's substitute those things into our formula. If we plug in 11,718 on the left, 3 on the right, and then in parentheses 1 minus 5 to the n, we actually can't combine the 1 minus 5. They're not like terms because 5 has the exponent. But in the denominator, we can do 1 minus 5. That would give us negative 4. So then we'd have 11,718 equals 3 times 1 minus 5 to the n, all over negative 4. Now we're trying to solve for n. What I would do now is get rid of the 3 and the negative 4 at the same time. I'm just going to multiply by the reciprocal. If I do that on the left side and the right side, on the left side the negative 4's cancel and the 3 cancels. That's the right side. On the left side we would get negative 15,624. If we take negative 4 times 11,718 divided by 3. On the right, we have 1 minus 5 to the n. I'll move 1 over by subtracting. And that just gives us negative 15,625 equals negative 5 to the n. I'm going to divide both sides by negative 1, which really just makes both the left side and the right side positive. 15,625 equals 5 to the n. Now you could check your power chart here because this would be power chart friendly. However, if it's not or you're not quite sure, we'll just log each side. I'll log 15,625 and log 5 to the n. That finally allows us to bring n out in front, giving us log 15,625 equals n times log 5. To get n by itself, we divide. Make sure you type this into your calculator, just so that we get a match. Log 15,625 divided by log 5 would show that there are 6 terms in that geometric series. And that does it for topic 6b. Use this information to complete your 6.7 Day 2 homework assignment on Pearson.